Hi children, hope you are all fine. Okay, we are going to study the remaining portions of the lesson motion. In the previous class, we studied what is distance, displacement, velocity, speed and acceleration. Now I am going to introduce you to some graphs. We have already seen that we use graphs in our daily life, isn't it? We have seen that we use the line graphs to solve the linear equations. We even use bar graphs to know the run rate when we watch the cricket match. In physics also we have graphs. Okay, here in this lesson we are going to study about two types of graphs. One is distance time graph and the other one is velocity time graph. So here one physical quantity is depending upon another physical quantity. When you take the case of distance time graph, distance is plotted along y-axis and time is plotted along x-axis. The distance time graph can be plotted for object at rest, object moving in a uniform motion and object in a non-uniform motion. The distance time graph will be a straight line parallel to the time axis if the object is at rest, and the distance time graph will be a straight line if it is uniform motion. If it is non-uniform motion, the distance time graph will be a curve. With the help of distance time graph, you can find out the position of an object at different instants. With the help of distance time graph, you can also calculate speed or the magnitude of velocity. So what will you do? How can you calculate the speed or magnitude of velocity with the help of distance time graph? For that, you have to take a distance time graph, then you have to plot 2 points between which you want to find out the speed of the object. From the point A, draw a line parallel to the x-axis. From the point B, draw a line parallel to the x-axis. Again from the point A, draw a line parallel to the y-axis. From the point B, again draw a line parallel to the y-axis. When you join it, you get a triangle. The slope of the triangle will give you how to calculate the speed, and the speed is given by, the speed can be calculated by the slope of the triangle, and that is given by S2 minus S1 by T2 minus T1. I hope you have understood what is distance time graph. Now let us go to the next portion, and that is velocity time graph. From the name itself you know that the two physical quantities here involved is velocity and time. In the velocity time graph, velocity is taken along y-axis and time is taken along x-axis. With the help of velocity time graph, we can calculate the distance travelled by the object. If an object is moving in a uniform motion, then the velocity time graph will be a straight line parallel to the time axis. If you want to find out the distance travelled by the object between the two time interval t1 and t2, from the time t1 and t2, draw perpendiculars to the graph. The region below the velocity time graph will give you the distance travelled by the object, or we will be able to know the position of the object, and that is given by the area of the rectangle. The region below the graph is a rectangle, so the area of the rectangle will give you the distance travelled by the object. Velocity time graph can also be plotted for uniform acceleration. In case of uniform acceleration, the velocity time graph will be a straight line. In that case also you can find out the distance travelled. With the help of velocity time graph, you can calculate the distance travelled. In that case, you have to consider 2 points. If you want to find out the distance travelled between the 2 points A and B, from the 2 points A and B, draw lines parallel to the x-axis and y-axis. And then when we join the line, the region below the graph will give you the distance, and it is a triangle and a rectangle. The sum of the area of the triangle and rectangle will give you, sum of the areas of the triangle and rectangle will give you the distance travelled by the object. Velocity time graph can also be plotted for non-uniform motion. In case of retardation, the velocity time graph will be a slanting line. In case of non-uniform motion, it will be just like a zigzag line. So I hope you have understood about these two types of graphs, that is distance time graph and velocity time graph. Suppose an object is moving in uniform acceleration. In that case, we can relate the final velocity, initial velocity, time, acceleration and position by 3 equations, and these 3 equations are called equations of motion. The first equation is V is equal to u plus at. This equation is called velocity time relation. V is the final velocity, u is the initial velocity, a is the acceleration and t is the time taken. The second equation is S is equal to ut plus half at square. This is called as position time relation. Here S is the distance travelled, u is the initial velocity, t is the time, a is the acceleration. In the third equation, we get 2as is equal to v square minus u square. This is called as position velocity relation. Here S is the distance traveled, A is the acceleration, U is the initial velocity and V is the final velocity. Now, with the help of a velocity time graph, we are going to derive an expression for all these three equations. We have to consider a velocity time graph, and with the help of that we are going to derive an equation. Suppose an object is moving with an initial velocity u, that is the initial velocity of the object is not 0. From the point A, it is moving with a uniform speed, that is the velocity is increasing at a uniform rate, that is it is changing from initial velocity u to the final velocity v, and A is the rate of change of velocity and t is the time taken. From the point B, you are drawing two perpendiculars to the graph, one to the y-axis E and one to the x-axis as C. Now, BC will be representing the final velocity v and OA will be representing the initial velocity u. From the graph, what is this BD? What is this BD? BD is same as BC minus DC. But what is DC? DC again is OA. So, BD is equal to V minus U. BD is equal to V minus U, and you have to keep this as one expression. In the next situation, we know that acceleration is equal to change in velocity by time taken. From the graph, what is the change in velocity? Change in velocity is BD by AD. AD again is same as OC, which is equal to time. So, BD by AD is same as BD by OC. That is same as BD by OC is equal to A. From here again what we get as BD? BD is equal to AT. When we combine these two equations, what do you get? We get V minus U is equal to AT, or V is equal to U plus AT. That is the first equation of the motion. In the second equation of motion, you have to consider, that is the region, we have studied that the region below the velocity time graph will give you the distance. The region below the velocity time graph will give you the distance. So, S is equal to area of the triangle ABD plus area of the rectangle OADC. The region below the graph will give you the distance travelled. So, S is equal to area of the triangle ABD and area of the rectangle OADC. What is area of the triangle ABD? It is same as half into BD into AD. And what is area of the rectangle OA into OC? So, you are substituting the values. What is the value for BD? BD in the previous equation we got BD is equal to AT. So, we are substituting, that is we are substituting S is equal to BD into half BD into AD. So, BD is same as AT into T, that is half AT square. And then what is the area of the rectangle? It is same as OA into OC, that is same as U into T. So, we are getting the expression S is equal to UT plus half AT square. This is the second equation of motion. I hope you have understood the first equation and the second equation. Now, let us move on to the third equation. In the third equation, we are considering the region below the graph as a trapezium. What is the area of the trapezium? Area of the trapezium is given by half into sum of the opposite side into adjacent side. Half into sum of the opposite side into adjacent side. What is that is half into sum of the opposite side is given by OA plus BC, which is equal to U plus V, into what is the adjacent side? It is OC, that is T. So, half into U plus V into T. What is this T? T can also be written as V minus U by A, that is from the first equation. From the first equation we know that V is equal to U plus AT. So, what is T from there? V minus U by A. So, when you substitute in the place of T V minus U by A, you get the expression 2AS is equal to V square minus U square. V plus U into V minus U is same as V square minus U square. So, that is how we derive the three equations of motion. What was the first equation? V is equal to U plus AT. Second equation was S is equal to UT plus half AT square, and the third equation is 2AS is equal to V square minus U square. I hope you have understood the derivation clearly. Now, let us move on to the next portion, the last portion in this lesson, and that is uniform circular motion. Suppose an object is moving in a rectangular track. How many times? It has to change the direction 4 times. We know that velocity depends upon speed and direction. When there is a change in the speed or when there is a change in the direction, there will be a change in the velocity. When the velocity change, there will be an acceleration. because acceleration is rate of change of velocity. So, when an object is moving in a rectangular track, 4 times it changes the direction. Here, sometimes the speed will be the same, but the direction will vary. When the direction vary, the velocity will also vary. So, when it is moving in a rectangular track, 4 times the direction changes and 4 times the velocity changes. When it is moving in a pentagonal track, 5 times the direction changes and 5 times the velocity changes because of the change in the direction. Here speed is same, but the direction is changing. When it is moving in a hexagonal track, 6 times the direction is changing. Each time when there is a change in the direction, there is a change in the velocity. Finally, as you go on increasing, like octagonal track, again 8 times the direction is changing, velocity is changing. When there is a change in the velocity, there will be an acceleration. As you go on increasing the side, finally it will reduce to a circle. That is, at every point there is a change in the direction. At every point there is a change in the direction. An object that is moving in a circular path with uniform speed is said to undergo uniform circular motion. In case of a circle, at every point there is a change in the direction. When there is a change in the direction, there will be a change in the velocity. When there is a change in the velocity, there will be a change in the acceleration. So, in case of what is this uniform circular motion? When an object is moving in a circular path with uniform speed, the object is said to undergo uniform circular motion. And we know that speed is equal to distance by time. In case of circular path, what is the distance? Distance is nothing but the circumference of the circle, and that is given by 2 pi r. So, here the speed is v is equal to 2 pi r by t, where r is the radius of the circle. Suppose you tie a stone to a thread and you just give it a circular motion. What happens? The point where you release the stone, it will move as a tangent to the circle. It is seen in some of the sports, like when we throw discus or when we throw hammer, we give a circular motion to our body so that the object will move in the desired direction. When we throw it, it will move as a tangent to the circle. Some other examples of circular motion is motion of the satellite around the earth, motion of the cyclist in a circular track. All these are examples of circular motion. Okay children, what are the things that we learned today? We learned about graphs. It is more precise if you represent things by using the graph, if you represent the basic information by using the graph. We studied about 2 types of graph, distance time graph and velocity time graph. And we also studied about the 3 equations of motion: velocity time relation, position time relation and position velocity relation. And we also derived these 3 equations by using a velocity time graph. We also studied about uniform circular motion. I hope you have understood all this content. Meet you in the next class. Bye children.